life cycle assessment is very much a process exercise, and what I'm going to do today is walk you through, because we've been talking about sustainability and we've been talking about environmental issues, and I'd like to give you a better understanding of what it takes to undertake a life cycle assessment, the pros and the cons, when you can use it and when you should avoid it. One of the biggest problems we have is we are constantly talking about green. We want to have a green product, we want to have a green business. Well, what does that actually mean? When you say green, you're really talking about a vast array of environmental impacts. And I guess my pet peeve is that we tend to focus on climate change. Everything is climate change. And I don't mean to suggest that climate change is not important, but it is only one of a range of environmental impacts, all of which need to be considered. In order to understand that range of environmental impacts, you simply cannot look at the manufacture of the product. You need to look at the extraction of your raw materials, the manufacture of the raw materials, the manufacture of the finished product, the use of the product, and how that end life of the product is addressed, and the transportation in between, and a set of myriad other factors. That entire process is called a life cycle assessment, or LCA. Why are we talking about that now? What's made this different? Well, I'd argue that we have gone through two phases of environmental thinking. The first phase, which started in the 60s, was primarily around factories. And at that time, our concern was smokestacks and drain pipes and what was coming out of them. The conversation was primarily about individual chemicals, primarily chlorine is a good example. And the conversation was pretty nasty. On the environmental side, they viewed business as evil, and you rarely had a constructive conversation. The consequences, the results, were regulatory, command and control regulation. And the problem with command and control regulation is it always sets a ceiling, it never sets a floor. So you only do as much as you need to get by, and that was the end of it. Consequently, it didn't have a whole lot of value to your customer. And so what most businesses did is they took the whole basket of environmental issues and they shoved it back down on operations, or they gave it to the health, safety, and environmental group, and they said, it's your baby, make it go away, I don't want to hear about it. The only time the business wanted to hear about it is if there was a problem. What's different? Well, we've got a range of issues now that are certainly more global than smokestacks and drain pipes. Climate change being one of them. I think the first was CFC phase-out, Montreal Protocol. And the focus is finally shifting to products. And in our arena, that is extremely significant. So we're now talking about vehicle performance as well as what's going on in the factories. We're also now finally beginning to talk about environmental impacts as opposed to chemistry. I guess one of my biggest pet peeves with regulators is they try to do our job for us. They assume they're smarter than we are about what we do for a living. And so we frequently would encounter design requirements as opposed to performance requirements where they're telling us you can't use this or you can't use that because we as regulators have decided that this is bad. Well, chlorine is a good example. Chlorine isn't the issue. Why do we talk about chlorine? Because chlorine turns into dioxins, and dioxins are bad. But why are we talking about dioxins? Well, in fact, dioxins are a contributor to the environmental impact, human toxicity. Toxicity is the issue, not chlorine. So the appropriate approach should be set us a performance target for toxicity and allow us to formulate to get there. Don't tell us what we can and cannot use. Thankfully, the approach in dealing with non-governmental organizations and regulators has become a little more cooperative. And in fact, One of my favorite pastimes is watching environmental groups fighting with each other, because some environmental groups are absolutely aghast that other environmental groups will actually talk to us. So the Environmental Defense Fund, which has teamed with a number of major corporations, the World Wildlife Federation have done the same. Well, they're in bad odor with the Sierra Club, and Sierra Club will go beating them up because they're actually talking business. But the good news is you can find environmentalists with whom you can talk on these issues. Most importantly, though, we're getting to the point where we're quantifying and therefore we're able to monetize environmental performance. And as soon as you can environmentally or monetize environmental performance, now all of a sudden the consumers are interested. And once the consumers are interested, my goodness, those customers are interested. And now all of a sudden it's on the table with business teams. So our business teams are looking at environmental performance, and that's why we're talking about life cycle study. This is simply a visualization of what we looked at back in the 60s, and that's what we're looking at today. It is a much broader, more complex set of issues. What's in a life cycle assessment? There are 4 parts to a life cycle assessment. Defining what it is you're looking at, collecting the data, assessing it, and then interpreting it. The most critical piece, I think, is scoping it correctly. Depending upon what you're looking at, you can influence the outcome. And the cynic would say that life cycle assessments are very much a case of you can get them to dance and sing however you want, depending upon how you define it. But for example, looking at a quart of oil, I'm going to get a different answer than if I look at the entire amount of oil the vehicle uses over its lifetime. And I might get a different answer if I look at the entire amount of oil used by a fleet of vehicles over their lifetime. Well, why might that be the case? Well, for example, if we're talking about extending drain interval, and by doing that, I'm going to have a certain number of premature engine failures out of a fleet. So for 1,000 vehicles, I might lose 10 vehicles or 25 vehicles because of premature engine failure. Then all of a sudden, I have to factor in that vehicle replacement into my life cycle assessment. I'd never get to that discussion if I was simply looking at a single quart. So it's an example of why setting your definition and scoping is critical. Inventory analysis. This is where you're looking at the collection of data, and that's usually the toughest part of an LCA, is going upstream from your suppliers and getting good data. Impact assessment is where you take that raw data and you translate that into the environmental impacts. But it gives you an example of the range of different environmental impacts that you have to take into account. This is simply a visual example of how one might use that range of environmental impacts to compare 2 different products using a spider diagram. Again, it gives you a sense of the performance characteristics. It doesn't necessarily give you the answers. This is simply data. What I think is most important about an LCA, though, is it allows you to identify burden shifting. Getting back to our regulators, the problem that we've had historically is they tend to focus on one issue. So a regulator would look at particulate matter, and they would set a regulation that focuses only on particulate, or would look at NOx, or SOx, or climate change. And they look at that one issue in isolation. And they don't think about how changing your product or your processes to get at that one issue might affect other impacts. 3 examples. I could increase one impact while I decrease another. So I'm going to reduce my resource depletion, but in the process I've increased my toxicity. Or I might shift it along the life cycle. I could decrease my acidification in my manufacturing phase, but I increase it at end of life. And third, I could simply take an impact and send it out of country. When I worked in the appliance industry, one of our plant manufacturers was very proud of the fact that they were no longer chroming parts. So they didn't have that environmental burden associated with chrome. I said, really? What have you done? Well, we gave it to a supplier to do. Still have chrome parts on the refrigerator. This is simply a hypothetical of how you can use that burden shifting in a defensive mode. If you think of that current product, I've got quite a heavy burden in the use phase. I could make the argument to justify increasing my manufacturing footprint if I can demonstrate that I have a significant reduction in my use phase, and the net is an improvement. Without an LCA, previously, you simply looked at the manufacturing phase. You were always pushing down the manufacturing burden. You were never in a position to be able to justify what that burden delivered in terms of performance in your use or disposal phases. There are still a number of challenges associated with life cycle assessment. First of which is consensus around methodology. Although LCAs have been around for around 10 years, and there's an expert community that's developed around it, primarily Germans. Nonetheless, there's an ongoing evolution on impact assessments and how they're done, constantly changing, constantly evolving. When it comes to data, if you don't have good data, it's been our experience that roughly 85%, maybe that much, of the data that goes into an LCA is insensitive to change. So going back upstream, if I can't get it, I can do a sensitivity analysis. And I'll take a given data point and I'll increase it by 200% and see if it changes the results. If it doesn't change the results, then I can set that bit of data aside and not be too concerned about it. My goal is to get at that 15% of data that really moves the needle and ensure that I've got a robust story there. Obviously, going upstream and downstream to get the data. For us, you have a used engine oil. It goes into a waste stream that includes a whole lot more than engine oil. And while in general, engine oil has made up roughly 2/3 of the waste stream in Europe and the United States, from an environmental impact standpoint, it's the other third, it's the industrial type chemistry that has really given the waste stream issues. So being able to parse out your elements and bits in the end-of-life challenge. How to make it affordable. Doing LCAs can be very expensive. And so the challenge is improving the methodology to make it useful on an almost all case basis. Ooh, what happened? I killed it. There we go. This is the critical issue. I had mentioned that the LCAs don't give you answers, they give you data. How much human toxicity is worth how much punishment? These are the trade-offs we're talking about. And if we only talk about climate change, you miss these other issues. This is what we need to be front and center, is understanding that full range of environmental impacts and the trade-offs that we're encountering as we go forward. And complexity. Again, this is an extremely complex exercise, a lot of data, a lot of analysis. How do we make it understandable? Now, I'm going to very quickly show you an alternative to traditional LCA. This is an approach by the natural step, and I'm putting this out as a bit of a warning. This organization, back in 1989, was created by a Swedish surgeon and came up with this analysis. I went for training on this when I worked for Electrolux. And this is the TNS analysis, which they call a funnel. This is not rocket science. They say we're using stuff up, and basis, if you were, every time you made a business decision, if you looked at these 4 criteria, they would help shape your direction. Okay, here are the criteria. First of all, you're not going to systematically increase in the biosphere material taken out of the Earth's crust. That includes not only heavy metals, it also includes fossil fuels. Secondly, you're not going to increase in the biosphere stuff that's artificially made, synthetics. Third, you're not going to cut down all the trees or fish out all the fish. And you're not going to replace all of the normal foodstuffs with biofuel products. And finally, you have to play nice and share. The reason I'm bringing this up as an alternative analysis to LCA is because this is out there. It may not necessarily be widely accepted, but it's an example of how environmental groups, well-meaning individuals, look at trying to get at LCA type thinking. And if you put that in the context of our industry, this presents a lot of issues. And what they then do, TNS, is they'll take those system conditions across a life cycle. I apologize, this is an eye chart, but basically what it does is they go through the process of looking at your life cycle and telling you how the different steps of your life cycle are impacted by those 4 principles. And then they come up with wonderful suggestions on how you can make yourself better. So in closing, let me simply suggest that you think about life cycle assessment as an important tool to understand your business, quantifying environmental performance, to ascertain whether or not it is a critical part of your value proposition for your customers, and use it, I guess how to recognize that you can use it as an advocate, but I would prefer you use it as a scientist. The first time we did one of these, it was on chlorine and engine oils. And I'll be very honest, when we all sat down and we were deciding whether to do this, we had a meeting where we sat around the table and agreed we were going to live with the results. Because they aren't always going to tell you what you want to hear. In fact, if there's one takeaway I leave with you, it's that LCAs frequently overturn conventional wisdom. And good luck. Thank you.
Thank you very much.